please raise your hand. Who doesn't know the meaning of SI units, please raise your hands. Okay, I think all of you knows what's the meaning of SI unit. Okay, I'll just write here SI units. Seconds. And finally, for mass, sorry for this. And for mass, it's kilograms. Okay, guys, I just said if anyone has an okay. So these are the fundamental quantities, and these are the fundamental units. These units have nothing, you cannot explain them using another units or another quantities. Length is just length, time is just time, mass is just time. Also, meters is just meters. There is no, there are no units that combine together to make meter, or there are no units that combine together to make a kilogram, and so on. This is the meaning of fundamental quantities and units. Derived units or derived quantities, from their name, I think you can expect what does they mean. They mean those are the quantities that need something to explain them, and this something is fundamental quantities. When you mix fundamental quantities by multiplying, adding, or multiplying, dividing, adding, or subtracting each other together, you make a derived quantity. Example for this is velocity. I think all of you guys know what's the meaning of velocity. Velocity, or let's say speed, not velocity. And I'll explain the difference between speed and velocity later. Speed is equal to, I think most of you knows, it's distance divided by time. Okay, so if we look at the equation of speed, we find it as said distance over time. Let's see, distance is what? It's length, right? So it's the equation of speed is something like length over time is just time. Okay, it's time. So to explain or to have speed is a quantity, right? But it's a derived quantity. Why? Because it needs length and time to explain it. Let's see now and convert this equation to units equation. What's the unit of length? We said it's meter, right? The SI unit for length is meter, and the SI unit, here it is, and the SI unit for time is seconds. So it's meter over seconds, which is the unit of, so we write here, unit of speed. Unit of speed is meter per second. We find that the unit of speed is a derived unit made of meters per seconds, right? That's the difference between quantities, fundamental and derived. Applications for such topic and such chapter or such fundamental that I've just explained. The main application for this is to be able to achieve or to know the unit of a quantity that it's first that you first see, or it's also a way that you need to use, or you can be able to use, or you use it to make sure that the equation you're using is right or wrong. Let's take an example. I'll clear all this right now. So if I told you that distance equals or let's say something else. If I told you that pressure equals force over area, I gave you this equation and I told you whether it's right or it's wrong. You need to decide. This is how you decide. This is the left hand side and this is the right hand side of the equation. You'll take the left hand side, pressure, and you know it's given. Let's say I gave you in the question that pressure unit is Newton per meter square. Okay, so you know pressure is converted or described in the units language by Newton over meter squared. Okay, and then you wanna describe the Newton. Newton is not a fundamental unit, while meter is. So we leave meter like it's a meter square. Nothing changes. But Newton, we need to change the Newton. Do you guys know the equation that says force? That force equals ma, mass times acceleration. If anyone doesn't know this equation, please raise your hands. Anyone doesn't know that force equals mass by acceleration, please raise your hands. Okay, I guess all of you knows that. So we all know that force is having a unit of Newton. So this means that Newton is made of mass multiplied by acceleration. So we can convert this to mass by acceleration. What's the unit for mass? It's kilograms. We know this. Multiplied by acceleration. What's the unit of acceleration? It's meters per second square, right? Anyone doesn't know that the unit of acceleration is meters per second square? If someone doesn't know, please raise your hand. Now we can simplify this equation or this units equation to kilograms meter. We turn the second square down, so it becomes meter square. Someone open the mic. Do you want to say anything? Okay. Simplify it more, so 1m goes with this square. We are left with kilograms over meter second square. Okay, so this is the fundamentals for pressure. Okay, so left hand side is done. We need to know and check right hand side. Okay, so it's kilogram. We reached that kilogram over meter second square. This is the left hand side. Now we check the right hand side. Right hand side was force over area. What's the equation of force? We just said it's mass times acceleration. What's the equation of area? Any area is like width by length, right? We need to convert these to fundamental quantities. M is a capital M, it's mass, times acceleration. It's also, we said acceleration is, just a minute, sorry for this. Mass fundamental unit is kilograms times the acceleration. We just said its unit is meters per second square, and this is divided by width by length. Width and length are both measured in meters, so meters times meters, right? Then we simplify what we simplify this equation, this units equation, to kilogram stays as it is, the first meter up stays as it is, then we take the s squared down, so it be, and here we multiply m by m, it makes m square times s square. We simplify it further, m goes with the m square, and we are left with just 1m, so it's kilograms per meter second square. This is the right hand side. What we found that right hand side is exactly the same as left hand side. Is this equation that I just I gave you in the beginning right or wrong? Well, I said that pressure equals force over area. Someone answers me, please.
It's right.
Yes, exactly. Why is it right?
Because in the end we got the same units.
Exactly. We found that the left hand side and the right hand side units are the same. So we say that this equation might be right. Let me give you guys this note. This equation mathematically is right because left hand side and right hand side units are exactly the same, but I can give you an equation where both sides give you the same units, but physically it's not right. So in this case, we have, while checking the equation is right or not, we have three cases. We have that left hand side is not equal to right hand side. Here we say it's for sure not right for sure. Then we have that the left hand side equals right hand side. Here we cannot say it's 100% right. We just can say it's either, it might be right, might be wrong. Mathematically it's right. Got this? Anyone didn't understand this part? I guess it's clear for all of you guys. So this is the topic that I was talking about. Any questions about the fundamentals? Any questions about the fundamental quantities, fundamental units, SI units? Okay. I'll also explain a small topic, another small topic. I'll explain I'll just go through the basics of scalar and vector quantities and just an introduction to both of them. Quantities is a big family of everything that you can measure anywhere. As I said, like length, time, mass, velocity, speed, distance, displacement, acceleration, anything that can be measured is called a quantity. We already classified these quantities to fundamentals and derived. This scalar and vector is also another classification that divides the quantities families to two types, scalar and vectors. Quantities are either having direction or doesn't have a direction. This is the main difference between any quantity and another one. And this is how you define a quantity actually, if it's does it have a direction or not. So scalar quantities are quantities that does not have a direction. Example for this, time, money. You do not say it's 5 o'clock to the right. You do not say I gave you $20 upwards or towards the south. You do not say give me 5 minutes south. So it's these are quantities that doesn't have direction, and they do not need direction to explain them. On the other hand, vectors need to be explained using a direction, giving them a direction. For example, I say that I walked 20 kilometers towards the north. I also say the car's velocity is 20 meters per second towards the right. I also say the displacement of this motorcycle is 20 meters towards the south or towards the left or whatever. So this is the main difference between scalar and vector quantities. So example for the scalar, as we said, this is the definition first of all: quantities that do not have direction. Example: time and money. While vector are quantities that need direction to be fully explained. Example: velocity and force. Okay. Let me explain to you guys a major difference or a main quantity that is present in both scalar and vector. Let's see. Distance and distance and displacement. What's the difference between distance and displacement? Distance is a scalar quantity. It doesn't need a direction to be explained, while displacement is a vector quantity. Distance, let me show you an example. If this is the start point and this is the end point, someone started walking from here. This is the end. Okay. Someone starting walking from here, and he took this path. He moved like this, then like this, moved a bit north, then he reached his destination. Okay. If I told you this is 2 kilometers, 3 kilometers, this is 1, this is, let's say, 5, and this is, let's say, also 4 or 5. Okay. What's the distance? What is the distance that this guy covered? You just say it's 2 plus 3 plus 1 plus 5 plus 4. You don't need a direction for this. You just say it's 2 plus 3 is 5, plus 1 is 6, plus 5 is 11, plus 4 it's 15. So you say distance is equal to, we said 15. So the definition of distance or explanation of distance is the distance or the length between the starting point to the end point from the path taken. The distance of the path taken between the start and the end, the length between the start and the end in the path taken. These are all definitions of distance. While displacement definition, it's called, or it's defined as the shortest length between the start and the end point in a straight line. So if we want to measure the displacement, we just take a straight line from the start to the end. This is the magnitude of the displacement. Let's say it came out to be 7. Just as an example, we say that the displacement, and displacement is notated or given by S, is 7. Then I need a direction. You can use bearing, you can use angles. So like if I said that if I assumed there is a straight horizontal line like this, and then I measured the angle between this line and the line of direction, let's say it came out to be 40 degrees, for example. We say here 40 degrees from the horizontal towards the negative, we can say negative, we can say lower vertical axis. We can also say 40 degrees from the east to the south, or 40 degrees southeast. Understood? If this part is understood, please raise your hands. If you guys understand the concept that I just explained, please raise your hands. I have 20 participants. I need 19 raised hands. I just have 7 raised hands. Guys, eight. I need 19, or at least 18. Anyone having any problems? If you don't have any problems or inquiries about the explained part, please raise your hands. If you don't have any problems, please raise your hands. Right. So this is the difference between distance and displacement. Let me go through one last thing, which is speed and velocity. If we say that speed is equal to distance over time and velocity is equal to displacement over time, someone please unmute himself and says which one speed or velocity is vector and which one is scalar. If we say that speed, who's answering? Who's answering?
Hold. Yeah, the vector one will be velocity because it has displacement over time. And the speed will be the scalar one because distance is not vector. It's not a vector quantity.
Exactly. So this means that while we measure speed, so let's say if I have a car that just moved in this path like this, and I told you that the length of the path is 20 or 200 meters, while the length of a straight line is equal to about 160 meters. Someone other than Hur tells me which length is scalar and which one is vector.
Speed is vector and velocity is scalar.
لا I mean which length is vector, which length is scalar.